Most people believe Southern California is safe from hurricanes, and on one narrow technical point they are right. But the reason lifeguards from San Diego up through Ventura have been running on empty for the past 2 weeks is not what most people expect. It is not the wind. It is not a landfall, and it is not a cone on a map creeping toward Los Angeles. It is water. Specifically, it is water that left the eye wall of a Category 5 hurricane named Genevieve, a storm whose center never came within 1,000 miles of the California coastline, and which is still arriving at the beaches of 5 counties as you watch this. The National Hurricane Center put Genevieve at 160 miles per hour and a central pressure of 925 millibars at 5 a.m. Eastern on Monday, July 27th, making it the first Category 5 anywhere on Earth in 2026, and the first major hurricane of the year in either the Atlantic or the Eastern Pacific. That storm is now unwinding over cold water somewhere north of Hawaii. The energy it manufactured is not. California does not get hurricanes. California gets their water, and that distinction is the entire story. Subscribe before we go further, because the swell window that just closed is not the last one this season. This is the part of the story that almost no one is telling. Before we get into the details, I want to be upfront about something. On its own, a high surf advisory in Southern California in late July is not unusual. It is close to routine. Summer south swells arrive from the southern hemisphere every few weeks. Lifeguards staff up, the surf gets good for 3 days, and life goes on. If you looked only at the wave heights from this particular event, you would file it under normal. What makes this one worth a full breakdown is not the number of feet. It is the source, the timing, and what the source implies about the next 4 months. California has no hurricane defense, because California has never needed one. The state's entire relationship with tropical systems is built on a single assumption: they die before they get here. That assumption is being tested this season by an ocean that is behaving in a way the coastline has not had to answer for in decades. Here is what the record shows. Genevieve was a tropical depression on Friday, July 24th, according to National Hurricane Center advisory data. By Saturday night, it was a hurricane. By Sunday morning, it was a Category 3 with 120-mile-per-hour winds. At 5 a.m. Eastern on Monday, July 27th, the NHC upgraded it to Category 5 with sustained winds near 160 miles per hour and a minimum central pressure of 925 millibars, a jump from roughly 80 miles per hour to 160 miles per hour in about 30 hours. Yale Climate Connections and the NHC both logged the ascent as textbook rapid intensification, with sea surface temperatures near 30 degrees Celsius, relative humidity above 80%, and light to moderate vertical wind shear. It was the Eastern Pacific's first Category 5 since Hurricane Christy in 2024, and the first major hurricane of the 2026 season across both the Eastern Pacific and the Atlantic basins. The storm never threatened land. It tracked northwest over open water roughly 430 to 500 miles southwest of the southern tip of the Baja California Peninsula, weakened through the week, dropped to Category 1 by Thursday morning with 80-mile-per-hour winds, and was forecast to dissipate about 1,000 miles north of Hawaii. The NHC advisory language on the coastal hazard was direct, and it was repeated across multiple products. Swells generated by Genevieve were affecting the Baja California Peninsula and reaching Southern California, where they were expected to cause life-threatening surf and rip current conditions. The National Weather Service issued a high surf advisory and a coastal flood advisory covering Ventura County beaches, the Malibu coast, Los Angeles County beaches, Orange County, San Diego County, and Catalina and Santa Barbara Islands. The Ventura County product, issued at 2:19 a.m. on July 29th, flagged evening high tides of 6.2 to near 7.0 feet through Friday night, with the highest surf from the Genevieve southerly swell arriving Wednesday and Thursday evening. Forecast swell reached 11 feet in San Diego County. Los Angeles County lifeguards reported close to 2,000 ocean rescues over a single weekend. As of this recording, the Genevieve swell has faded, the advisories have expired, and the water is still moving. To understand why a storm that never came close can still empty a lifeguard tower, you have to understand what a hurricane actually manufactures. Think of the ocean surface under a major hurricane as a drumhead being struck for days without pause. The wind does not just push water around locally. It transfers energy into the surface in a way that organizes into waves, and those waves carry that energy outward long after the wind that made them is gone. In shallow water, waves drag on the bottom and burn themselves out fast. In the deep open ocean, they lose almost nothing. A swell generated southwest of Baja can cross more than 1,000 miles of Pacific and arrive in Newport Beach having spent only a small fraction of what it started with. The storm is a factory, the ocean is a conveyor belt with almost no friction. The part that trips people up is speed, and it has a name: dispersion. Waves in deep water sort themselves by period, which is the number of seconds between one crest and the next. Long period waves travel faster than short period waves. A 20-second swell moves across open ocean at roughly 35 miles per hour in terms of the speed the energy actually travels, which means a swell born off Baja on Monday shows up in Southern California on Wednesday. That is why the surf arrived after the hurricane had already begun weakening, and it is why the biggest waves of the event landed on Thursday, days after Genevieve had stopped being a Category 5. The public reads the headline about weakening and relaxes. The water has not received that message. Dispersion also means the swell announces itself before it commits. The longest period waves arrive first, small and widely spaced, which is exactly the trap. A beach that looks calm on Wednesday morning is a beach that is being fed by the front edge of an energy pulse. Period is also where the danger multiplies, and this is the number that almost no forecast graphic explains properly. Wave energy scales with the square of the height and the square of the period. Double the height and you have 4 times the energy. But hold the height steady and double the period, and you also get 4 times the energy. A 4-foot wave arriving every 8 seconds and a 4-foot wave arriving every 20 seconds are not the same object. They look nearly identical from the sand. One of them will knock you down, the other will take you off your feet, hold you under, and drag you 100 yards along the beach before you get a breath. Southern Hemisphere summer swells typically run in the 15 to 18 second range. Hurricane swells from a rapidly intensifying storm in the eastern Pacific arrive steeper and heavier for the same measured height. And that is the specific reason the National Weather Service reaches for the words life-threatening on tropical swell events and not on ordinary summer surf. Then there is what long-period waves do to geography. A wave feels the seafloor when the water depth drops to about half its wavelength. In deep water, a 20-second swell has a wavelength on the order of 2,000 feet, which means it starts interacting with the bottom in roughly 1,000 feet of water, far offshore, long before it reaches any beach. That early contact bends the wave. It refracts, the way light bends through a lens, and it focuses energy onto specific points of coastline while starving others a mile away. This is why a hurricane swell is never evenly distributed, and why the title of this video matters. From San Diego to Ventura is not a figure of speech. Every county on that stretch owns south and southwest-facing beaches, submarine canyons, jetties, points and offshore islands that concentrate a south swell in ways a west swell never touches. The wedge in Newport Beach exists because of this focusing effect. So does the flooding at Seal Beach. So does the exposure at Pierpont in Ventura. Same swell, wildly different outcomes, decided by bathymetry nobody can see from the parking lot. And the rip current mechanism sits on top of all of it. Every wave that breaks pushes water onto the beach, and every gallon of that water has to return to the sea. It does not go back the way it came. It finds the path of least resistance, a gap in a sandbar, the side of a jetty, the mouth of a channel, and it drains through that gap as a narrow, fast river running perpendicular to the shore. The bigger and more consistent the surf, the more water is being loaded onto the beach per minute, and the harder that drain runs. A strong rip can move faster than an Olympic swimmer. It does not pull you under, it pulls you out, and it exhausts you while you fight it, which is the mechanism behind the overwhelming majority of surf zone drownings in this country. But here is the part that almost no one is covering. The wave story is downstream of an ocean story, and the ocean story is only getting started. NOAA's Climate Prediction Center issued its Eastern Pacific Outlook on May 21, 2026, calling for a 70% chance of an above-normal season, with 15 to 22 named storms, 9 to 14 hurricanes, and 5 to 9 major hurricanes. For the Central Pacific, NOAA forecast 5 to 13 tropical cyclones with the same 70% chance of above-normal activity. Set that against the 1991 to 2020 Eastern Pacific averages of 15.4 named storms, 8.3 hurricanes, and 4.2 majors, and the top of NOAA's range is close to double the normal number of intense storms. In the same release, NOAA called for a below-normal Atlantic season, 8 to 14 named storms with 3 to 6 hurricanes and 1 to 3 majors. That contrast is not a coincidence, and it is not noise. It is the fingerprint of El Niño. El Niño is the warm phase of a Pacific-wide oscillation, and it does 2 things that matter here. It warms the eastern equatorial Pacific, which is fuel, and it collapses vertical wind shear over the eastern Pacific basin while increasing it over the Atlantic, which is permission. Shear is the difference in wind speed and direction between the ocean surface and the upper atmosphere. High shear tears a developing storm apart before it can organize a core. Low shear lets it stack vertically and spin up. El Niño quietly removes the thing that has been suppressing eastern Pacific hurricanes, which is why the same climate signal that is expected to hold the Atlantic down is expected to open the Pacific up. NOAA declared an El Niño advisory in June 2026. The Climate Prediction Center's late July update states that El Niño is present, that it will strengthen through the end of the year, and that there is a 97% chance it persists into early spring 2027. NOAA's June release put the odds of the Niño 3.4 region exceeding plus 2.0 degrees Celsius, the threshold for a very strong event, at 63%. This is where the story gets genuinely complicated for California, because the state has almost no institutional memory of what a very strong El Niño does to its coastline in summer. The three benchmark analog years are 1982, 1997, and 2015. Across those 3 seasons, the Eastern Pacific averaged roughly 23 named storms, 12 hurricanes, and 8 major hurricanes. The 2015 season alone produced 26 named storms, 16 hurricanes, and a record 11 majors, with accumulated cyclone energy near 290, one of the most active seasons ever measured in the basin. Accumulated cyclone energy is a single number that combines how strong storms got and how long they stayed strong, and a value near 290 against a long-term normal near 100 tells you the basin was not just busy, it was running at roughly 3 times its usual output. Every one of those storms is a wave factory. Most of them never touch land, all of them point energy somewhere, and the Eastern Pacific's most common track, northwest and away from Mexico, aims a large share of that energy at the southwest-facing coastline of Southern California. The season so far is tracking the signal rather than the exception. By the end of July, the Eastern Pacific had produced 6 named storms, while the Atlantic had managed 2. Hurricane Fausto, the basin's first hurricane of the year, was tracking toward Hawaii, while Genevieve was still spinning up, and swells from Fausto were already hitting Southern California during the same weekend that Los Angeles County lifeguards recorded close to 2,000 rescues. 2 separate tropical systems, one basin, one weekend, both delivering water to the same beaches. That is what an active Eastern Pacific season looks like from the sand, and the calendar says the basin has not reached its most productive stretch yet. The Eastern Pacific season runs through November 30th, and the climatological peak for major hurricane activity has historically fallen from late August into September. Fox Weather noted that the average date for a Category 3 in the Eastern Pacific is July 15th, meaning Genevieve arrived close to schedule for a first major, not early. The storms that follow it are the ones the outlook is actually about. There is a second layer underneath even that. The cascade risk on the California coast is not drowning alone. It is drowning plus infrastructure plus timing. Long-period south swell does not just break on beaches. It runs up piers, into harbor mouths, over seawalls, and into low-lying streets, and when it coincides with a high evening tide, the two stack. The Ventura County Advisory on July 29 called out exactly this arithmetic: evening tides of 6.2 to near 7.0 feet, arriving at the same hours as peak swell. Water level is additive. A swell that is harmless at low tide becomes a flooding event 4 hours later without changing size at all. And every coastal city in Southern California maintains its seasonal defenses on a winter schedule. Sand berms go up in the fall. Summer is when the beaches are widest, the crowds are largest, and the physical protection is lowest. A season that delivers repeated tropical swell into August and September is a season that tests that assumption over and over at the exact time of year when the most people are standing on the sand. To see what that looks like when it lands, go back to a specific street. Seaward Avenue in the Pierpont neighborhood of Ventura runs down to the beach and ends at a low wall. On the morning of December 28, 2023, during a high surf advisory at high tide, a series of large waves cleared that wall and pushed straight up the road. Video released by the Ventura County Fire Department shows people standing on the pavement watching the ocean, then turning and running as the water comes through, catching some of them and carrying them into parked cars. Ventura County Fire Captain Brian McGrath told reporters afterward that 8 patients were transported to hospitals in Ventura and Santa Barbara after surf came over the wall and flooded the streets. Fire crews had originally been called to help 2 surfers in distress. The rogue set turned a rescue into a mass casualty response inside a few minutes. That swell came from a winter storm in the North Pacific, not a hurricane, which is precisely the point. The water does not care about the label on the storm that made it. Seaward Avenue is still there, the wall is still the same height, and the neighborhood behind it is still one badly timed set away from the same afternoon. The present tense version of that story is in San Diego. Lieutenant John Maher of San Diego Lifeguards, speaking to News 8 as the Genevieve swell was filling in, described the conditions as a lot of really strong rip currents and big surf, and said lifeguards were making upwards of 100 rescues a day. Those are not surfers in trouble. Overwhelmingly, they are ordinary swimmers who walked into the water at a beach that looked normal, at a moment between sets, and were 50 yards offshore before they understood what had happened. Every one of those rescues is a person who lived because a tower was staffed and someone was watching. The towers come down in the fall. The swell season does not. To keep this danger properly in proportion, some honest numbers. The National Weather Service documents surf zone fatalities nationally, and the annual totals it has published in recent years run in the range of roughly 100 to 110 deaths, counting rip currents, high surf, and sneaker waves together. The typical victim in the NWS data is male, between 10 and 29 years old, and the highest concentration of deaths falls in June and July. Set against tens of millions of beach visits, the individual risk of any single trip to the water is very low. This is not a mass casualty hazard in the way a landfalling hurricane is. Nobody's home is going to be destroyed by a swell event from a storm 1,200 miles away, and the flooding these events produce is generally measured in parking lots, walkways, and ground floor rooms rather than in leveled neighborhoods. But what the data does and does not tell us matters more than the raw counts. What it tells us clearly is that the deaths cluster in exactly the conditions this season is producing more of: warm weather, big crowds, elevated long-period surf. What it cannot tell us is which specific beach, on which specific day, will have the fatal rip. There is no forecast product in existence that can name that. What it also cannot tell us is how many tropical swell events are still coming. The seasonal outlook gives ranges and probabilities, not dates, and anyone giving you a date for the next one is guessing. The honest position is that the Climate Prediction Center's numbers describe a basin with substantially more capacity to produce these events than a normal year, that the season runs through November 30th, and that the historically most productive weeks are still ahead rather than behind. Compare that to 2014, when Hurricane Marie sat well offshore as a Category 5 and sent swell into Southern California that destroyed piers on Catalina Island, caused an estimated $3 million in damage there, damaged pilings on the Malibu Pier, destroyed a historic lifeguard station at Point Mugu, flooded a 4-block section of homes in Seal Beach, and killed a surfer near Malibu. Marie never made landfall anywhere. The lesson from Marie is not that every distant hurricane produces that. It is that the ceiling on what a distant hurricane can do to this coastline is much higher than the average event suggests, and the seasonal outlook is a statement about how many chances the ocean gets to reach for that ceiling. So here is what to actually do with this, and all of it is about your agency rather than your fear. Check the surf and the tide separately before you go, not just the wave height. A high surf advisory that overlaps an evening high tide above 6 feet is a different event than the same surf at low tide, and the National Weather Service publishes both. Swim within sight of a staffed lifeguard tower and ask the guard what the water is doing that hour, because conditions on a long period swell change dramatically between morning and afternoon. If you get caught in a rip current, do not swim back toward the beach against it. Swim parallel to the shore until you feel the pull release, then angle in, and if you cannot swim out of it, float and wave rather than exhaust yourself. Here is the counterintuitive one that saves the most lives. If you see someone struggling, do not swim out after them empty-handed. Bring something that floats, a boogie board, a cooler lid, an inflatable, anything, because would-be rescuers make up a meaningful share of surf zone deaths, and a person with flotation can hold position until help arrives. Stay off jetties, rock walls, and wet sand on long-period swells, because the set that clears a jetty arrives after a lull that makes the jetty look safe. If you live in a low-lying coastal block, move vehicles off the street and clear ground floor spaces before an advisory window rather than during it, since the flooding arrives with a tide cycle you can see coming hours ahead. And if you surf or paddle, treat a tropical south swell as a different animal from a southern hemisphere swell of the same height, because the shorter travel distance means more energy per wave and less warning between sets. 3 things to watch over the coming days. First, the National Hurricane Center's Eastern Pacific Tropical Weather Outlook, which as of the 5 a.m. Pacific issuance on Monday, August 3, shows no tropical cyclone formation expected over the next 7 days. A genuine lull and not an ending, because the basin has produced 6 named storms already, and the season runs to November 30. Second, the Climate Prediction Center's next ENSO diagnostic discussion, scheduled for August 13th, which will update whether this El Niño is still on the track toward a very strong event. Third, the National Weather Service coastal hazard products for Los Angeles, Oxnard, San Diego, and Ventura, which are where the next swell window will be announced before it appears in the news. I will be watching the NHC Outlook and the CPC ENSO update closely over the coming days, and I will come back with a full breakdown the moment the next system spins up, because the storm that produces the next California swell has almost certainly not been named yet. Subscribe so you get that one when it lands. What comes next is not written yet. Stay safe out there.